Thank you. So a quick bit about who I am. So I am the CTO at a company called Kentu. You can find us in our booth if you want to talk to us about all kinds of OSGi things and the CenterNet project. And I've been involved with OSGi for a long time now. I'd love to claim longer than anyone in the room, but Peter's sitting right there. So I've been a committee representative for the OSGi working group. I'm now on the steering committee as part of Kentu's representation there. I do lots of stuff with IoT and distributed systems. I've written an OSGi book back in the day. But what we're going to be talking about today is none of those things. We're going to be talking about the feature launcher. So firstly, what is the feature launcher? Well, kind of unsurprisingly, it's something that launches features. And I promise it's going to get better than that. So we need to start really by talking about the feature service, because when I say we launch features, we kind of need to know what features are. So the feature service is something that gives us a schema and an API for manipulating a feature, where a feature is a definition that provides groups of bundles that should be installed, some configurations that should be created in the runtime, and a bunch of other metadata. But what it is at its heart a document that is describing a deployment, but it doesn't, crucially, contain any of the deployment. So you may be asking why we have this at all, because we've had deployable bundles for a really long time, and we've got the configurator that can deploy configurations. And part of this is that sometimes you do need a higher level artifact. You can version a feature. You can version bundles, but you can't really version a group of bundles. So the feature is offering that versionable artifact. You also have a single place where you're defining the whole deployment, which is a nice thing to have. And the features themselves are distinct from the bytes of the bundles. So they're quite small and lightweight to share. If you're trying to give someone a definition of what you want them to have, you're not shipping over a whole framework and every single bundle. You're just shipping over a document. Is that a question? Oh, I don't know. I thought I saw a hand briefly pop up. So back to the launcher. People often talk in OSGi about the concept of a management agent, where for a long time the management agent has been broadly unspecified. It's this magical beast that is capable of controlling and setting up your framework, and mostly it's been left as an exercise for the reader. And features were no different. You had this API to create and manipulate the documents, but there was no way to actually cause them to be installed. So what we need is a solution to this. And the feature launcher is intended to be this solution. It's a management agent that will spin up a framework for you and install everything that is listed in the feature document, and do so, hopefully, in a relatively easy way. Ideally, with zero code required. So this is where I do my first very easy bit of demo, which is to show that we can launch normal Java launch command here. And we're using the feature launcher, and we have installed GoGo and a bunch of bundles using the feature launcher CLI. Not a very exciting demo, but kind of the purpose of the feature launcher is not to be super exciting. It's to make this easy for people who don't know their way around an OSGi framework particularly well. So the first question is, where did the framework come from? We said this feature document is just a JSON file, so we needed a framework from somewhere. Well, there are some defined rules in the spec that say where we have to look. One of the fallbacks, and the fallback that was used in this case, is to look on the class path to find a framework factory and launch the framework, which is exactly what the OSGi specifications would suggest you do if you were looking to write your own launcher. Obviously, we don't want to grab bundles from the class path. Sorry, what is it, Jane?
Is there a hook for doing that differently?
Oh yeah, there are defined rules. That's a fallback. It's not the only rule. So what about the bundles? We do not just look on the class path for bundles, don't worry. This is one of the things that was a sticking point when originally defining the feature service, and why it took a little while to get a result on what we wanted from a management agent, which is we need the concept of a repository from which we can find these things. And that's why you saw we had this -a flag in the command, where we had a URI where we were pointing, in this case, at a folder on my laptop, because I was told that the Wi-Fi here might not be great. It's the first year that they've been here, and I thought I'd better off not trying to pull things from the sky. So artifact repository is the interface from which we find the bundles that we can install, and you can create one of those things from an artifact repository factory. It allows you to find a bundle by ID, or it will return you null. You can use this factory to create repositories. The ones that it's required to support are Maven layout on the local file system or remote using HTTP. Now, implementations can support way more than that if they choose to, but you are guaranteed that those two things will always work with all implementations, which represents, I would argue, 90 to 95% of all usage of Maven repositories. You can configure certificates if you need to, you can configure credentials for logging into the remote thing, but fundamentally most people are using Maven repositories by HTTP with a local cache. You may ask why we didn't use the existing OSGi repository format. And the reason is that actually it does a load of stuff that we don't need. We don't need all the bundle metadata. We're not looking to do a resolution. There are many more Maven repositories in the world than there are OSGi repositories. And actually, you can quite easily make an artifact repository wrapper over the top of an OSGi repository if you really want to. All you need to do is be able to map the Maven coordinates to a resource in your OSGi repository, which is done by pretty much all of the common repositories out there that can recognize you have a GAV. So, having shown you one demo, I thought I might show you something slightly more interesting this time. So we've heard about these repositories that we might want to use. So if we look here, let's make you a little bit bigger. So you can see here, we are using the service loader to find and load our feature launcher implementation, because this is, remember, not running in OSGi. We are bootstrapping from raw Java in our main method. If we don't find one, great, we blow up. Once we've found one, we are creating a repository. So the feature launcher is an artifact repository factory. You can create one separately if you want, but you can just use. Here we're resolving a repo on my local file system, and then we're creating a reader to this go-go-JSON, which is just a standard feature JSON, which is in here. You're not zoomed in. So you can see here, normal feature document, list of bundles. I haven't defined any configurations, but it's all just exactly as you'd expect. And then we do our launch. We say we want to launch our feature with the repository that's going to find our bundles, launch the framework, and then a standard framework wait for stop, which is basically our way of saying, please don't exit while the framework's still running. So if I run this as a normal Java application, thank you. I could have sworn I told you to be nice and big. I'm going to fix this now because we are actually going to need this. Where have we not got? Come on. There we go. So now, list the bundles. You can see we have exactly the same bundles running. all nice and easy, and you can integrate this into whatever application you want if you need to fire up your own OSGi framework. So, again, all pretty simple, pretty easy.
One question regarding the repo. You mentioned it's using also Maven repos. Is it using the Maven implementation, or has it been re-implemented to just use the layout?
So
the question is intended on the usage of the Maven configuration, which you also mentioned.
So that is an implementation decision. The implementation that is the one being written by, amongst other people, me, is using the Maven Resolver API to set up the repositories. I am not in the business of rebuilding Wagon and then Wagon's replacement. I am in the business of saying, oh look, there's a really good, well-maintained open source version of exactly the thing I need. I should probably use that. So yes, we use that for the remote. The local, we have implemented basically just something that follows the layout, because all you're doing is running through some folders. So that's kind of pretty easy to do with no Maven dependencies. We are considering whether that's the right call or whether to just continue using the Resolver API. The main reason for keeping the local one separate is it might let us do a light version where you opt out of having the remote Maven stuff, but it shrinks the implementation down by about 8-9 megabytes. So yeah, there are pitfalls to using the Maven stuff as well as advantages. It's not small. So you may have noticed that the demos so far have been pretty basic. And that's the feature launcher is great, but it has a very simple use case, which is it's a one-shot startup deal. You know, it's about bootstrapping your framework, and after you've done it, there's not really anything else for the feature launcher to do. There is no way that you are going to change the bundles that have been deployed. But OSGi is supposed to be this dynamic environment. We need a runtime version of the launcher if we are going to take advantage of this dynamic environment. And this is where we come across the feature runtime. So feature runtime is a service that you will find in the service registry, and you can think of it as a bit like a feature launcher, but that acts on the current framework. So rather than creating a new framework for you, it's going to actually make changes in the running OSGi framework that it's part of. You can install as many features as you like. You can remove them again. It's obviously not possible in this case to be zero code. And the reason it's not possible to be zero code is that you need to be actually acting in a running framework. You need something that is going to trigger this process. You're going to need to integrate with the service. But it is dramatically simpler than trying to manage it all yourself, because there is a service that you can give a feature and say, please make this stuff happen, and then you just wait for it to be done. So using the feature runtime is pretty easy. You can introspect what's currently there. So we have get installed features, which will list everything that is installed, including what bundles and configurations were installed for that given feature. You have the ability to add things into the runtime using install, and you have the ability to remove stuff again using the ID of the installed feature. Finally, you can do an update, which will take an existing feature and make the ideally minimal set of changes needed to reflect a new feature that you want to deploy in its place. So, we go back to the framework. We will hopefully see from a very similar launch, it's doing almost exactly the same thing. But this time, you'll see we have rather more bundles deployed. And that's because we've got all of the bits needed for the feature runtime, including, as you can see, the Maven artifact resolver implementation, which is what we're using for all of the remote repository resolving. So I have created a couple of simple go commands, which are, in this case, listing install features. We can add feature A, and you can see we have a hello world from A, which has installed a bundle for us. Just to prove that it's not a one-shot deal, we can also install B, which again has installed something completely different. If we list them, you can see we've now got 2 features installed. And if I want to, I can remove one again. And if we look now, you can see there's a hole where bundle A used to be. And if I list, we only have 1 feature installed now with 1 bundle. So all of this, it again, is looking pretty basic because I'm using small features, mostly because I want you to be able to see what's going on quite zoomed in. But this will scale to features of arbitrary size. You could be deploying tens or hundreds of bundles if that's what you need to from a single feature. Is that a question?
Yeah.
Great.
What if I remove the bundle manually at the module level? What would happen with the feature scope?
So if you remove the bundle manually, then you're into the Wild West. It's not going to stop you. I don't even know if there is a hook that would prevent you from uninstalling the bundle. There are hooks that you can use to prevent it resolving. There are hooks you can use on collision, but I don't think anyone could stop you. If you do that, then great, you're into your own very specific use case. And well done and good luck with managing that.
Okay, I have another one. So what would happen if in an earlier version of a feature I have a list of bundles, and then in the new version I have some of the bundles removed, and then I want to install the new feature right now, but an updated version of the same feature which has been installed, but it has some bundles that have been removed from the previous version.
Give me 5 to 10 slides. We'll get there.
One more question to follow up on that. Is there something like a feature lifecycle? So I know that all of the bundles within the feature have arrived at active state or something like that?
When the install returns, it means all of the bundles will have been started. So part of the contract of the feature is when you say install this feature, it means run through and potentially set start levels, potentially change the framework start level, but wait until all of the operations that are necessary for installing and starting the feature, as defined in the feature launcher spec, is done. And then it returns control to you and says, right, you're ready to go. If it were to fail, it would be making a best effort to return the framework to the state it was before. So depending on the point that it starts failing, sometimes it's not possible to get you exactly where you were, but there's a defined order to which it has to do things, and it basically gets as far through as it can do before doing anything destructive like uninstalling a bundle. So, yeah, I don't think there's anything more to show in the demo just there. So, back we go. We've been dealing with bundles so far, but configurations, I've mentioned they're in there. They are just as, if not more important than bundles a lot of the time. Configurations are what really allow us to get the exciting dynamic behavior we want from our components. They allow us to control how things wire together. Responding dynamically to configuration is what makes OSGi services and OSGi applications really dynamic in a way that most other things can simply never be. The format looks like the configurator JSON because it's basically the same. And both the feature launcher and the feature runtime will install configurations for you. Obviously, this requires that a configuration admin service is available. And feature startup will by default time out if no configuration admin service has become available before the timeout expires. Now, in order to allow launching to work, what that means is configurations will be installed as early as they can be, but it will not block the bundles from being started, because it may be that one of the bundles you're starting is configuration admin. So you end up in a horrible bootstrapping problem. So it simply waits, and as soon as configuration admin becomes available, that's when your configurations are created. Because they are created eagerly, in general, if they can be, particularly for things like the feature runtime, configurations will be created before the bundles that use them are started. So you won't have the typical start up with no configuration or incorrect configuration and then drop, get reconfigured and come back up. You don't get that kind of double start bounce that you sometimes see with so management agents like file install, where there's a couple of seconds delay sometimes before it does the initial load of configurations. You see all the bundles come up and then half the bundles go boop, boop, as the configs get put in. We've tried to do our best to ensure that that will only happen if it really has to, rather than happening most of the time. So if we go back to our still running framework, I can now install, let's make sure I get the names of these right. So yeah. So you can see here I've added the configuration for B that was still running, and my component's been reloaded with the name OSGi Summit that it's greeting instead of me that it was greeting previously. But what we can also do is reinstall A and the config at the same time. And what you'll see is that we didn't get, as I said, we didn't get that double bounce. It made sure that the configuration was installed as early as it could be in the process, and therefore by the time that the bundle was installed and started, the configuration already existed for it to consume, and there was no period where it was saying hello someone else. It was always using OCX 2024, not world. Now, for some advanced usage. Decorators and extensions. So OSGi features allow the concept of something called an extension, which provides additional information about what should happen with the feature. Extensions are in general optional, but they can be mandatory. If an extension is mandatory, it means that there must be something that processes that mandatory extension. And if there is not, then you must fail to do anything with the feature because you don't fully understand what it is. There are some pre-processing and extension handling parts of Feature Launcher and Feature Runtime already. So we have something called a feature decorator, which is called for every single feature and given the entire feature. And then we have a feature extension handler, which is registered with a name and called for the named extension. So feature extension handlers are how you process extensions in features. Both types of decorator have the ability to modify the feature before it is installed, meaning you can literally totally rewrite it if you choose. You could start installing totally different bundles if that's what your decorator really needs to do. More commonly, you won't dramatically change the set of bundles, but you could, if, for example, you're a runtime like Carafe, you could use your decorator to take a feature as some input and do a resolution and then maybe add in some additional bundles to take a feature that is partially complete and turn it into something that's transitively closed. That would be a valid use of a decorator to make something more easily deployable as a feature. There are some built-in extension handlers, which include framework launch properties, framework implementation selection, where you'll actually have the ability to tell the feature launcher what framework it should be using, and the feature launcher will have to go and query its artifact repositories to find that framework implementation. And if you make that extension mandatory and none of them are available, it will blow up and it will say, I could not support any of the list of frameworks that you told me that I should use, therefore I can't find them, I can't run. But otherwise you give it a nice ranked list of use this framework, or this framework, or this framework, or
Yeah,
pop.
the problem is lower down than that, because we don't start a Java process and then load something into it. We start binary directly.
In which case you're not using the feature launcher. You're into your own custom launcher.
Yeah.
So there are then extensions for feature variable mapping. So feature variables are effectively placeholders. They allow you to, it looks a little bit like specifying configuration for your feature. They can have default values. Sometimes they have no default value. If you have a variable which has no default value and you try and use it in the feature, then it will blow up. And so that means you need to provide additional variables when you're doing your launch or when you're doing your runtime install. But you can have extension handlers that will effectively process the feature and will inline all of the variable mappings so that you have something that you can actually deploy at runtime. You have extension handlers for setting default bundle start levels. So you can actually control the start level for each of the bundles you install, and you can control the target start level for your framework at the end of installing the feature. So this is useful for situations where you maybe want to install a feature that needs a progressive start, where you want to bring up one set of bundles and then the next set of bundles and through, which is what start levels were really designed for. Or perhaps you want to install a feature and then have the target framework start level set so that only part of the feature is actually started at the point that the feature is finally installed, and you leave the rest for the management agent to, at some point later, decide that it's time to complete the start of all of the bundles in the framework. And also, as I mentioned, configuration creation timeouts are something that can be set in an extension. You can tell the feature launcher or the feature runtime how long it should wait for a config admin to appear before it considers that no config admin is going to come along and it can't install your configurations, so it better switch everything off.
So how does it find the right Java virtual machine? I mean, different frameworks might have different dependencies on virtual machines, right?
So that would be, again, you would put extensions in there. If you have something where you're actually going to have a hard requirement, then you can put other information in there. But we're short of digging into the class bytes of the framework that we're going to try and create. Certainly for the feature launcher, we'll find out as soon as we try and load the framework factory. If we're in too old a version of Java, that will blow up, and it will blow up big. So it's pretty safe in that sense. And then for the rest of the feature installation, it will fail fairly quickly because the bundles themselves will have a required execution environment that's not matched.
There's no dependency mechanism or anything where you can say, oh, give me a Java 21 VM, give me a...
So the feature launcher is started by calling Java -jar. So the person who's done that has already decided what Java version is being used. It's not starting outside Java and starting Java. It's starting the Java process is the thing that's launching the framework. Decorators, there aren't any ones defined in the standard because there aren't any use cases we've identified that are sufficiently common and necessary. But anyone can provide one. You could use it very easily to blacklist bundles. You could say, you may not install this feature because it contains this bundle that I don't like, maybe because of its license, maybe just because you know that version has some security hole in it. Whatever reason you want, you can just say, nope. You could look at the feature as a whole, validate some signatures perhaps, and say, yes, this is good, it's been signed by someone I trust. In all cases, the decorators and the extensions can make changes to the feature before it actually hits the framework. So you can rewrite it just a little bit, not at all, or completely. It could be very different by the time it hits the runtime. Now, runtime merging. And this is one of the biggest differences between the feature runtime and the feature launcher. Is the feature launcher always starts with a clean framework with basically nothing in it, and it's responsible for seeding that initial set of bundles. The feature runtime, on the other hand, can install multiple features which may overlap. It may then remove things, and you'd have to deal with the fact that you're removing something that's needed by more than one feature. Or you can perform an update where in your update operation, some of the bundles may stay, some of them may change version, some of them may disappear entirely. All of this results in conflict, and there are different ways of dealing with merging in the feature runtime. We can register something called a merge handler that will be called for every situation that's identified where there is something that may or may not be a merge conflict. There's a separate handler for dealing with bundles and a separate handler for dealing with configurations. The bundle handler will be called basically any time that you have a bundle that has the same group ID, artifact ID, but different version. And if you're in that situation, it will say, here's the bundle that I've been told to install. Here's the set of bundles that have that I think are potential clashes. What do you want to do about that? And the merge handler will have at that point the ability to potentially not install the new bundle, potentially install the new bundle and leave everything else alone, potentially install the new bundle and remap the existing features to use that new bundle, resulting in the old bundles being uninstalled. And the reason that it does that is to allow you to do things like deduplicating in your runtime. There's probably no point in you having Jackson 2.16.0 and 2.16.1 and 2.16.2 all installed at the same time. You can probably fairly safely say we only need one of those versions. And it's up to you whether you say the one that's already installed is good enough, I want to be minimally disruptive, or I should use the newer one because newer is always better, or some mix of the two. So the big thing about bundle merging is that you are responsible for determining which of the features that were involved in the conflict end up with which bundles at the end of it. So you can completely change everything round. You could end up with all of the bundles being installed but mapped to totally different features if that's what you really want. But you have full control for resolving that. And the default, if you do nothing, is that everything gets installed. Configurations are slightly different because the clashes there are determined by PID. And if it's a factory configuration, it's the PID and the name together, both of which are defined. And if you've got two features that are trying to deploy the same configuration, the default behavior of the runtime is that the latest configuration wins in its entirety. But you may wish to introduce something that does, for example, a merge, where you overlay the properties from one configuration over the top of the other so that you get the union of the two of them, with the later installation taking precedence if there are clashes. Or you may choose to go the other way and you only add the properties that didn't exist previously. Or again, you may choose to do something completely different. So it is absolutely possible for you to try this out. There is a demo available that was the stuff that I was showing on GitHub. It's using the like 70-80% feature complete implementation of the feature launcher. The feature launcher draft specification is, we think, done. It's hard to say this for certain until the TCK is finished and we're passing all the tests, but we're relatively confident that the spec chapter is done. It's visible if you go and look at the latest spec snapshots. The implementation, the feature launcher is completely working. Feature runtime is broadly working. If you found bugs in the merging part, I would be less surprised. But that's the, broadly speaking, we're at the point where you can use this now if you want, try it out. There is still opportunity for some feedback. If you spot something that's really glaringly, obviously wrong, then please tell us. If there's something absolutely critical that you want to do and think you can't do, again, tell us. We might be able to tell you how you can use the existing API to do it, or you might genuinely find a hole that we can close before everything gets wrapped up. So, thank you, everyone. That's the feature launcher.
One question, is it an alternative to the B&D launcher, or is it possible to combine these two to create an executable jar with a B&D configuration that uses the feature launcher inside?
So you could absolutely have a B&D executable jar that created a framework containing a feature runtime that you use to deploy features. That would absolutely work. It would not really make sense to try and mix the feature launcher and the B&D launcher, which are trying to do effectively the same thing.
Okay, so it's the B&D launcher with feature runtime.
Yeah.
And the feature launcher would be an alternative.
You could have an exporter that would create a launcher configuration.
Yeah, you could absolutely. So something I would be looking to work on in the future, once time allows, would be something to allow you to export a B&D run as a feature, or export potentially a partial B&D run as a feature. So B&D runs are usually fully resolved, and it might be that you already have effectively some of the bundles deployed as part of your base feature, and you want to extract a feature from a B&D run. So you would effectively need to take the difference between existing features and your resolved B&D run, and that would be your new feature. So there's some work and some thought needed there, which is why I haven't just gone straight in like a bull to try and make it work. But absolutely, there's a very strong and close mapping between the stuff that's in a B&D run file and the stuff that would be in a feature JSON.
Thank you.
Yep.
Is a feature always a flat collection of bundles, or can I say my feature contains another feature?
So you are absolutely not able to do that within the feature spec, but you could very easily do that with an extension, and then you can have an extension processor which will run through to find the feature, inline the feature, and you're away, because the artifact repository is just given a Maven ID. So if you have the Maven ID for your feature, you can ask your artifact repositories for the feature bytes, load it in, read it. Yeah, it's exactly the kind of thing that you could do really easily with with extension processing.
Okay, so going from this, obviously you know Karef.
Yes.
You also know the feature thing from Karef, probably.
Yep.
Which supports depending on features. So this is the difference. In what other points does the feature launcher compare to the Karef feature thingy, and how? So
the feature launcher and feature runtime are very much treating the feature document as a prescribed list. That what they're not doing is going to do anything other than what that says exactly. Whereas a Karaf feature is relatively common for Karaf to take one or more features, smush them together, perform a resolution, and then deploy a set of bundles as a result, which may involve some deduplication of what was across the multiple features, and almost always involves some additional bundles being deployed, because a Karaf feature is slightly more like a BND run with its run requires than a BND run with its run bundles, whereas a feature JSON is a bit more like a BND run with its run bundles. The feature JSON is, here is the list of bundles to deploy, whereas a Karaf feature is, here is a list of bundles that I want to make work. You are welcome to do some additional processing to make that work for me. So is a slightly different goal there. But for a carafe feature that was marked as complete, then yeah, it's kind of very similar to a feature JSON.
So technically, could I, going forward, deploy feature launcher features in carafe, and does that have any, is there an advantage to that? Or should I just not bother about that if I'm already in an infrastructure where I'm using carafe features?
So you would absolutely be able to, and the advantages come basically in and around things like tooling support and availability of features. So if lots of people start providing feature documents, feature JSON, and Carafe is able to natively install those, that is an advantage for Carafe users. Equally, there is no pressing reason to say, Carafe, you must stop using your feature documents. Keep using them, they're fine. BND, keep using BND runs. It's not intended to replace it, it's intended to finally get people to the point where they say, what is the OSGi way of starting a framework? And there has never been a good answer that we can give. We can say, oh well, you could do this, or you could do this, or you could do this, or you could do this, depending on what implementation thing you want to do. And they say, I just want to use a framework. They got the framework factory, and then they said, that's really nice, but I don't want to have to write any code. My users are afraid of writing code.
It was actually the use case for GoGo, Tiny Shell.
Mm.
That one was integrated with a framework. I think Parimas actually
Yeah.
implemented it that way.
Yeah.
I mean, isn't this a little bit use case dependent? I mean, if I have to start 1,000 devices, I might want to do something different than if I just start one. Right?
So,
I still want the feature description, I still want the facility, particularly the runtime, but I'm not sure the feature launcher helps a lot of that.
So, well, it depends how your 1,000 devices are started. But yeah, if you've got 1,000 devices and you need to homogenize them, then that seems to be the point where containerization and an orchestration platform is designed to solve that. It's not for someone who wants to do Java minus jar. The feature runtime may be more useful to you because you can issue it, but that's why you have very much two parts of the specification. You have the bootstrapping a kernel that does some very basic stuff and setup, and then you have the actually managing a runtime, which is a more complex task.
When will you upload it? It's not yet available. You just mentioned it. You will upload it.
So what I need to do is I need to push the small change that I've been trying to keep in sync with small spec changes that have been made as the implementation's gone through, and we've needed to make one or two minor changes in the API, basically renaming some constants that were badly named. So I was trying to avoid having something really chopping and changing in public. I just need to click the make it public flag. It's already uploaded.
Might have time for one last question, because then we need to...
Yeah, I have a scenario of this question. So let's say that I have a full-fledged JSON file
Yep.
with all the features specified there. I got it installed, so all the features installed by default, all the bundles is installed that belong to all the features. And then I update one of the features in the runtime.
Yep.
In the feature runtime service. Now let's say that I shut it down, shut the runtime down, and then I start the runtime once again using the same feature, JSON descriptor. Now what would happen, because one of the features actually stays in an older version, and then that includes, is there any way to say that whenever I start the feature launcher, we should always use or kind of flush the whole storage and use the bundles that have been specified in the feature JSON?
So that's down to framework storage clean on first init. That will wipe it out for you as you go in, and everything is fresh as a daisy.
Yeah, but in that case, all the configurations that have been modified in the runtime, that's also gone.
Yes, but if you want to inherit the existing framework state, you're not using the feature launcher with a feature at that point. You're saying please inherit the state.
I'm mapping the Wesleyan agent use case.
Yeah.
Okay. Yeah.
So in that case, yes, don't clear out the framework cache, and you what I would suggest at that point is you should also not be providing a feature to install, because all your bundles are already installed.
But if you want to use the runtime feature